All right, so this lab is called molar mass of a solid. And so what we've got here is some kind of unknown solid. And we want to find its molar mass, right? It's the first step in identifying what a compound is. And so to do this, we're going to use a colligative property known as freezing point depression. And what this colligative property states is that solutes will lower the freezing point of a liquid. And so it works according to this equation, in which the change in the temperature of the freezing point is equal to the constant times the molality. And so here, molality, remember that means your moles of solute over your kilograms of solvent, right? Kilograms solvent. So we can plug that in to get this equation. And then another thing that we can do is rewrite our moles of solute as the grams of solute divided by the molar mass of the solute, right? So mm will be molar mass in units of grams per mole. And so you can see we have molar mass in here. We can plug that into the equation. And now our equation is Kf times the grams of solute times 1 over the molar mass, all divided by your kilograms of solvent. And then remember, our change in freezing point here is going to be equal to the freezing point of the pure stuff minus the freezing point of our solution, right, after we've added some solute. Some other pieces of data that you can see that we're going to need to get is our grams of solute. That's pretty easy to get. We just weigh it out. Our kilograms of solvent, again, that's also pretty easy to get. We just weigh it out. And then our Kf, we can pull that straight from the literature depending on the compound. And then all we have to do here is solve for the molar mass of the solid, right? So to do this, we're going to do this in kind of 3 steps. The first step that we're going to do is find the freezing point of our pure solvent. In this case, it's cyclohexane. Right, we're going to find the freezing point there. Second thing we're going to do is we're going to add some solute and then find the new freezing point. Right, and so between these two numbers, we should be able to find the molar mass of our solid. And then we'll just do another one. We'll add more solute and find the freezing point again, just as a check, right? So you don't really have to do step 3, but it's always good to do multiple trials of your experiments. And so basically what you're going to be doing is looking at a thermometer as your cyclohexane cools down. So some data you're going to want to record is the time. And your lab manual says to record about every 30 seconds, which I think is pretty good idea. And then you're going to want to do trial 1, which will be your pure stuff, right? Your pure cyclohexane. You'll write down the temperature in degrees Celsius at each time interval. Then you're going to do trial 2. Now you add in some solute into here. So you'll find your degrees Celsius, write down those numbers. And then you'll do trial 3, which is even more solute. And so you can see we've got some data. Next thing we're going to want to do is plot this data on a graph. So on the left here, the y-axis will have degrees Celsius. On the x-axis, we'll have time. And what you should see is basically the freezing point depression, right? You're going to put this in to some cold solution. The temperature is going to drop very rapidly, and then it's going to begin to freeze. When it begins to freeze, the temperature is actually not going to change. And then once it's all completely frozen, it will then continue to change, right? So it'll look something like this, where this area right here, whatever that corresponds to, that will be your freezing point of your pure solvent. And then you're just going to repeat again with the solute, right? It's freezing point depression, so it should be lower. This one might not be as straight of a line, but I think in our case, it'll be a pretty straight line, right? So it'll stay about the same temperature. It'll change a little bit, but not too much. And then it'll change quicker once it's all frozen. And then your freezing point here is going to be the midpoint of this line. But for our experiment, I think it'll be actually relatively straight, just because we're not too precise here. So that'll be kind of trial 1. I guess technically trial 2. And then finally trial 3, that should lower the freezing point even further. And so that'll look something like this, right? Where this area right here, whatever that corresponds to, that is your freezing point. And I would recommend graphing this in some kind of computer program, perhaps Excel or Google Sheets, that's free. Or if you really want, you can do it by hand. I would suggest using a computer. This is something that computers are good at, right? Tedious work and doing it quickly, right? So you want to graph those 3, extrapolate the data, and then find the molar mass of your unknown. And then another kind of question we want to ask ourselves with this lab is, how precise is this experiment? Right? How good of a number are we getting here? And we have to think about the equipment that we're using here. So our kind of limiting factor is actually going to be a thermometer. Right, so just draw this little block that's going to indicate my thermometer. Down here, I'm going to have 0 degrees Celsius. Up here, 10 degrees Celsius. Big line for 5 degrees Celsius. And then kind of 4 markers in between each, right? And then the liquid in the thermometer is red. So maybe you read it as something like this, right? All of this is red right here. And then you can read this thermometer, right? We know it's above 7, but below 8. So we know for sure that it's 7 point something degrees Celsius. And then remember, we're allowed to estimate one number. So maybe I read that as 7.7 degrees Celsius, right? This number is kind of your guesstimate number. And so you can see that this value only has 2 sig figs, with the second sig fig not being very accurate. And so if you think about the math and think through the sig figs here, overall, our answer for the molar mass won't be very precise due to the limitation in the instrumentation that we have. But we will get in the right ballpark. Right, so if you're wondering how could we make this more precise, right, the first thing you want to kind of think of to look at is a more precise thermometer. Maybe one that's been calibrated to do 0.1 degrees instead of 1 degree intervals. And so you might be asking, well, why don't we use a more precise thermometer? And that's because the more precision your instrument has, the more money it costs, right? So there's kind of practical limitations here. But overall, it's a very cool experiment. You'll see the colligative properties here. You'll see that they do indeed work, and we'll get in the right ballpark for our answer, which is very nice. All right, so first thing we're gonna do is get our mass of our test tube. So I'm gonna put a beaker in here to hold the test tube, tear it out, and then place the test tube in here and then record a mass for it. And now that we have the mass of the test tube, we're gonna add 10 mils of our cyclohexane that I have already poured into this graduated cylinder. So we'll just pour this into here. And then get the mass, so we get the mass of our cyclohexane. Cool, so we got that. All right, so I got my ice bath down here. I got my cyclohexane, so go ahead and lower that into the solution, to the ice bath. And then lower my thermometer with attached copper stirring thing. And then what you want to do is basically just record the temperature every about 15 to 30 seconds. Note that this 1 is 10 and then the 2 is 20. See, something like that. It's probably a good angle right there while I stir. All right, so at this point you can see our temperature is dropping again, so that means everything is frozen, so we can go ahead and conclude this section of the experiment, lift everything out. Right now it's all frozen together. You can see that the cyclohexane is indeed frozen. So we'll just go ahead and let it heat back up. It'll melt away, and then we'll add some other compound to it and see how that affects the boiling point. All right, so you can see our cyclohexane has melted back into a liquid, so let's reweigh it. It is possible that some of the cyclohexane evaporated away, so we got a tared beaker in there. Weigh it up. Got that mass right there. And now we need to add 0.1 to 0.2 grams of our unknown. For unknown, we're going to choose unknown A right here. So we'll take a piece of weigh paper, fold it in half, like so. And this will just make it easier to transfer that liquid, or this solid, into the test tube. Put it in here, tear it, and then using correct weighing technique, weigh out about 0.1 to 0.2 grams of our unknown. All right, so there we go. We got some of our unknown. And then we'll pour this into our test tube. And make sure to get it all in there. You see how folding the weigh paper earlier helped us transfer. Always think ahead. And then you just want to give it a little swirl, just make sure to get all the solids nice and dissolved. Otherwise, you're going to get some error in your experiment. And you can use your copper stir bar to make sure everything is nice and dissolved. And now we're ready for trial 2. All right, so now we're ready for trial 2. Got my ice bath. Go ahead, lower my solution into here. Lower my thermometer with my stir. And then you want to go ahead and record the temperature while I stir. All right, so at this point, the temperature drop, or the rate at which the temperature dropping is increased, indicating that everything's frozen. So we should be able to take all this stuff out. Should have enough data. And as you can see, it is indeed frozen. So we'll let this melt back to liquid, add some more solute, and do one more trial. In case you want to watch it melt, it's pretty cool looking. You can use your hand to help speed up the process. All right, at this point you can see it's all melted away. Take it out of here. Dry off the outside. And then we'll reweigh it, add some more solute, and do one more trial. All right, next up we'll want to reweigh our test tube with our material in it, because it is possible that some of the cyclohexane has evaporated off. So we'll tear this beaker. Get that to read 0. Take the mass of our test tube. There we go, got that. And now we're going to take some more of our unknown A and add another 0.1 to 0.2 grams. And then repeat the experiment. Again, fold this up nicely so that it's easier to pour. In there, tear it up. Use proper weighing technique. There's how much we'll add for our second trial. And remember, whatever we added for that first trial is still in here, so it's going to be an additive effect here. So get this in here. Go make sure everything's dissolved away, and should be good to go. All right, it's trial 3. Here we go. There's our ice bath. Here comes our cyclohexane solution. Straight into that ice bath. Then here comes our thermometer with the stir. Go down until you reach the bottom and then just lift up a bit. That way it's not touching the bottom, but it's close. And then we just stir and read our temperature. I can feel it getting harder and harder to stir.